Okay, in this video, we're going to look at the relationship between linear speed and angular speed. The formula that we know is distance is equal to rate times time. But instead of distance here, let's change it to s, and let's make our rate equal to velocity, and we'll call that times time. Okay? So we're still using our distance is equal to rate times time, but here we're going to say that s is equal to v times t. Now the variables don't matter, but what we're going to do is we're going to talk about it in the context of something that's moving around the outside of a circle. Okay? If we decide that we want to solve for v, we're going to get s divided by t. Okay? Now, we also want to talk about the amount of angle that gets spun around. So if I take theta here and I'm standing here, this is going to be going around and around and around here, this part, but my angle is also changing as well. Think of it as if you're standing at the very middle of a merry-go-round. You're not actually moving, but you're spinning around, and your perception of the angle that's moving around, changes, right? But that angle doesn't change whether you're standing here or standing here or standing out here. The amount of that angle is going to be the same regardless of how far you are standing from the center of that circle. Now we can measure that, and we use this Greek letter omega here. Looks like a little W like this. And that's equal to theta, and we divide that by t. Now we can combine these two formulas together. We know that S is equal to R times theta. And we know that because we previously looked at that when we looked at arc length up here. So now I can say, okay, well, instead of S, I'm going to do S over T here, and I'm going to do over T here as well. I'm going to divide both sides by t. Now I know that S over t is equal to v. And then I have omega over t, theta over t is equal to omega. So I now have this relationship, and this represents angular speed. Let's think about this, what this represents. The velocity that you are traveling on the outside of the circle. So you're here and you're traveling around here. You're playing crack the whip with your friends and you're getting spun around, right? That's going to be equal to the amount of radius that you have times how fast that angle is changing. Okay, so let's say you're on the merry-go-round and you're right here. Let's say that merry-go-round is 20 feet wide and it's spinning around at 180 degrees a second. Well, that's going to be pretty easy to figure out how fast you're going. Problem is that we have to make sure that we use radians. So we have to make sure that we go, okay, I'm going to 180 degrees per 1 second. I'm going to convert that into pi over 180. So that's going to be, I'm going to do pi radians per 1 second. And this is how fast that angle is changing. That's my omega. So now how to figure out how fast you are going on the outside. That velocity is going to be equal to the 20 feet that you have there times pi over 1 second. So you're going to feel like you're going 20 pi over second. Now, in this case here, we can leave it in terms of pi, but we actually probably want to get like a good decimal answer here because we want to figure out how fast we're actually traveling. So I'm going to do 20 times 3.14, and I'm going to get 62.8. So the amount of velocity I have is going to be 62.8 feet per second. And that's how fast I'm going to feel like I'm traveling around this merry-go-round. So now here's an interesting thought. How fast are you? How fast are you traveling right now? Now, we all know a little bit about Einstein, or we know his name anyway, but he has this theory of relativity. And what that theory of relativity states is that, you can feel like you're not moving even though you might be going really, really fast. And so that speed depends upon your reference frame. Now, we're sitting here on the surface of the Earth, but in actuality, we're moving pretty fast. We're moving like, well, we'll figure that out. How fast are you? So the velocity that we're traveling is equal to the radius times the amount of angle that we have. So we have to figure out what is the radius of the Earth. So I'm going to Google it here. What is the radius of the Earth? 3,959 miles. Okay, good to know. So now, how fast are we moving? Well, one revolution is 24 hours, right? Because the Earth spins one revolution every 24 hours. Okay, so I know that I have one revolution every 24 hours. But this is not in radians. So we have to be able to convert this to radians. I know that if I go once around the circle, that's 2 pi revolutions. And now let's see what happens. I'm going to cancel out my revolutions. And I'm going to do the math here. I'm going to do, and I know you guys can't see this, but I'm going to type it in anyway. I'm going to do 3,959 times 2 times pi. I'm going to divide that by 24. And I'm going to get 1,036 miles per hour. And that's actually how much we're traveling on the surface of the Earth. Now, we don't feel it because we're moving around in inertia and all that physics stuff, but that's how fast we're actually traveling around the surface of the Earth relative to our solar system. All right, good luck with these word problems, and if you have any questions, use the Ask My Instructor feature and let me know if you need help with any of these. Good luck.